Imagine the nervous system as the body's communication highway. Every thought, movement, and reflex depend on tiny electrical messages traveling through nerve fibers. Some messages crawl slowly along the road, others leap forward at lightning speed. Today, we'll uncover how nerve impulses travel, why some nerves are faster than others, and the rules that all nerve fibers must obey. Before we dive in, let's define conductivity, which is the ability of an excitable membrane to carry an action potential along its length. This property exists in nerve fibers, muscle fibers, and cardiac muscle. The nerve fibers come in two main types: myelinated nerve fibers and myelinated nerve fibers. In unmyelinated fibers, we see contiguous conduction. Think of this like a human chain passing a heavy bucket of water. Every single millimeter of the nerve membrane must depolarize. It's continuous, but it's slow. It burns a lot of metabolic energy and found in small diameter nerves, the myocardium, and smooth muscle, while in myelinated fibers, the nerves is wrapped in an insulating fatty layer called the myelin sheath, created by Schwann cells. But there are gaps in this insulation called nodes of Ranvier. This creates saltatory conduction. It's from Latin, which means to jump. The electrical signal skips the insulated parts. Depolarization only happens at the nodes of Ranvier. Its velocity is up to 50 times faster than the unmyelinated fiber and consume less energy. Now to the laws of nerve excitation. 1. The law of anatomical and physiological integrity. A nerve works only if it's intact. If a nerve is cut or damaged, excitation cannot pass. 2. The law of isolated conduction. Only the stimulated nerve fiber conduct the impulse. The action potential doesn't jump to neighboring fibers. Why? Because in unmyelinated fibers, they are separated by connective tissue, and in myelinated fibers, they are insulated by myelin and Schwann cells. 3. The law of two-way conduction. If a nerve fiber is stimulated, the action potential travels in both directions. This applies to both myelinated and unmyelinated fibers. But in real life, physiologically, impulses move in one direction only, because synapses allow transmissions one way from presynaptic to postsynaptic neuron. 4. The law of low fatigability. Nerve fibers do not fatigue easily. They can conduct impulses for long periods. And 5. Different rates of conduction. Not all nerve fibers conduct impulses at the same speed. Speed depends on 1. Fiber diameter. The larger the diameter, the faster the conduction. 2. The presence or absence of myelin, in where myelinated fibers are much faster than the unmyelinated one. These laws ensure messages reach the right place on time every time. In the end, the nervous system doesn't rely on randomness. It follows precise electrical rules, uses insulation to save energy, and adjusts the speed to meet the body's need. From a simple reflex to complex thought, everything depends on how efficiently nerve impulses travel. Before moving on, pause for a second. Let's test what you've just learned with a quick quiz. Question number 1. Which of the following statements about saltatory conduction is correct? A, B, C, or D? Question number 2. Which of the following factors most increases the speed of nerve impulse conduction? A, B, C, or D? If you learned something cool today, smash that like button and hit subscribe for more bite sized medical lessons. Drop your answers and questions in the comments. Until next time, stay curious.